Well, good morning, AP Chemistry. I'm going to try this again. Bryce, I think sometimes I might need your help. Sometimes I make a video and it kicks into slow motion mode. I don't know what it's causing that to do that. I'm sure it's user error. You're probably laughing loud at this particular moment in time. All right, problem 3 on the exam. I wanted to go over that today. And because I'm trying to teach you guys how to do a voltaic cell. And I've seen so many of these problems on the exam over the course of time that I want to make sure that it's covered. Now, before we get started, I want to point out a couple things. Make sure you get your exam in front of you. You need to pause the video at this point to do so. That's fine. I wanted to point out a couple items. First of all, they give us the reduction potentials. And I went ahead and listed one has to be oxidation. So I went ahead and switched this one to an oxidation potential because that's the only way it's going to give us a positive voltage. Now, I want to say something a little bit. I had a little discussion with Hannah. When you're adding, and some of the others noticed me doing something similar, and adding and subtracting significant digits. Every how many places past the decimal could be that many past the decimal in the next number. So yes, this has 2, that has 3. Does not mean this answer only has 2. Since that goes 2 places past the decimal, this can go 2 places past the decimal. Also, I've seen sometimes they'll even include a little bit more. So just be careful with your significant digits rule. But again, if you can add and subtract, then you should be okay on that. And I don't know if they're going to try to trip you up on that or not. And I forgot the 3 here. Also, on your balancing equations, when they don't have full compounds, don't forget that the total charge must be balanced. So a way to check your work, especially with a base solution or an acidic solution, is check the charge. We have 3 times plus 1 is plus 3, so this side is plus 6. And here we have 3 times plus 2 is plus 6. The charge is balanced. That means the equation is balanced. I know that's not part of what was asked of you on this particular problem, but I wanted to go over it. Okay, we've done part A. It says calculate the standard potential for this particular cell. We've done that. So it's 1.34 volts. Question B says the mass of the platinum electrode, does it increase, decrease, or remain the same? Well, platinum is not involved in the reaction. You see that copper 1 is going to copper 2. That's the reaction occurring here. So the platinum electrode will not change its mass whatsoever. Obviously, the gold electrode will increase mass, but the platinum electrode is not changing mass. So the answer to B is that it remains the same. Okay, now number C, I want to see if I can if I can hold this for you so you can see it, but you should have your thing right in front of you. If you look here in box A, this is plus 3, plus 3, plus 3, so we have plus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 at negative 1, so it's balanced. On the right-hand side, we have plus 3, plus 1 for potassium, plus 1, so we have plus 5. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, so negative 9. So therefore, B cannot happen because it does not have a balanced charge. Remember, that's what this salt bridge does, is help the charge to remain balanced in the beakers. If the charge is not balanced, the reaction has to stop. Okay, so in letter D, then it says, after the cell is operated for 30 minutes, 0.185 of grams of gold has deposited on the gold electron. Calculate the number of moles. I won't write that down. You know how to do that. 0.185 grams divided by 196.97 grams of gold to 1 mole. Your answer is 9.39 times 10 to the negative 4th moles of gold. Now, I wrote this down to get to the next part of the problem. Okay, so D, that's the answer to D. To D, part 2, it says calculate the average current that passed through the cell. We're told in part 1 that this happened for 30 minutes. Okay, so how do we get current? Well, this is where we have to look at Faraday's law. 1 mole of gold needs 3 moles of electron. Okay? Now, 1 mole of electrons is 1 Faraday, and 1 Faraday is 96,485 coulombs. Now, you might be able to leave this step out and say 1 mole of electrons is 96,485 coulombs. I've done it both ways. I've seen it both ways. I don't know if you have to absolutely have to have this step in. And then 1 minute is 60 seconds. Okay? So look at your units. Minutes, of course, cancel. Moles of gold cancel. Moles of electrons cancel. Faraday's cancel that with coulombs per second, which by definition is an amp. So that equals 0.151 amps. So by definition, then we have defined what the answer is, what they're asking you to find there. Okay, in E, they give you a table. It says, based on the following table, determine the density of the precipitate. Justify your answer with the calculation. Well, they tell you that CuCl2 is 5.2 moles per liter. So that's very soluble. So what we have to do then is show why would it be CuCl as a precipitate. So what I did was say that CuCl is Cu plus 1, Cl minus 1. The KSP is given to us at 1.7 times 10 to negative 7th equals x squared basically, and the copper ion and chloride ion must be equal to each other, which when you do the square root of that, you get 4.1 times 10 negative 4th molar. And we're told the solubility of the other one was 5.2. This is less than 5.2. So CuCl is the precipitate. Don't forget to answer the question they've asked you, okay? Just doing this is great, but you got to say CuCl be the precipitate, and here's your justification. And they give 1 point, I noticed on here, for doing that, and 1 point for identifying that. Then it says write the net ionic equation for the precipitate. And so you have to put Cu, don't forget you've got to show these as ions, plus chloride yields CuCl as a solid. So there's your net ionic reaction. So you have to show that. And then letter G, the last one, says the student predicts that the cell voltage will increase after the precipitate forms. Do you disagree, or do you agree or disagree and justify your answer? Well, you disagree, because think of this as a battery. This is disappearing. You're using this up. It says that it decreases, right? So it decreases. The battery's not going to have as much available reactance, so it's going to decrease. You could also calculate Q. You know the Nernst equation now. You don't have to calculate. You could just put the Nernst equation down and say Q, therefore, would increase because of this decreasing, right? This is going to decrease, so therefore Q would increase, which means then it's going to cut into potential of the cell. And so anything like that would be a way of justifying. So hope this helps you gain a good understanding of this. And I'll work on more of these later as you want, but at least want to get you good and started with cell. I've seen this on at least 2 or 3 different exams, and so I wanted to introduce this to you. So hope this helps. That's it for now.